Hi there, friends. It's Ben again. This is a video for the Calc 1 class. We are taking a look at an assignment that asks you to make use of technology, and the way that it actually phrases it is to look at appropriate uses of technology. Okay, and that particular phrasing there is because sometimes we tend to just turn to technology, trust it blindly, and not really think about what's going on with it. So a lot of what I want you to concentrate on is, when do you need to use technology, and when could you figure out solutions without using really hardly any technology at all? Okay. So with regard to that, I am going to bring up a website real quick here and try to show you something to do with some graphing. Okay, so with the share screen here, I shouldn't, oh, nope, that was the wrong thing. Sorry, share screen, and I need to just go over to Chrome. All right. This is a website that probably a lot of you have seen before. It's referred to as Desmos, just desmos.com, and then it will take you to the calculator section once you accept something on it. You can totally sign up for accounts on it, and that allows you to do some extra stuff with saving things. I have an account, but I always just log straight into it and just do what I need to do. So not super hard to get stuff going with. So, all right. So the thing I'm going to do here is based on something that is in your textbook. And so I am bringing up here on the side a quick view of something from the textbook. I just need to remind myself of what the function was that we were going to look at. So, yep, there it is. Okay, so the question, this is actually example 1 from section 1.7 in your text. And it says, how many roots does y, come on, y equals x to the 9th minus 20x plus 1 have? Okay, so on your screen there, you can see what looks like, you know, just 3 red lines that are almost vertical and stuff. And if we go and click on the points that it's kind of highlighting there, it looks as though you've got 3 x-intercepts and 1 y-intercept. Okay, the y-intercept of 0, 1 you could have gotten from just plugging in x equals 0, no problem. But the equation that you're trying to solve there, x to the 9th minus 20x plus 1, when you set it equal to 0 and try to solve, that's how you get to your x-intercepts. Now, if you have taken an algebra class, you assuredly have gotten the idea that when we talk about x to the 9th, you should expect up to 9 roots for it. We only have 3. What happened to the other 6? Well, the other 6 are going to end up having to be complex numbers, and they would come in conjugate pairs. We really don't have much in the way of tools to figure out what those are, but we can see what these real valued ones are by looking at it with a simple graph like this. Now, if you want to take a look at that graph, though, you're going to need to zoom in a bit. But if you notice, as I said zoom in, zoom out a bit. As soon as I zoomed out, suddenly everything looks like vertical lines and you can't really tell what's going on. If I zoom back in, it's super hard to both get the range set up where I can see those peaks and where I can see those x-intercepts at the same time. So I need to know how to do something over here with clicking on, I'm assuming it shows you the pop-up window, but I don't know for sure. When I clicked on the picture of the wrench, it says something about projector mode and reverse contrast. I don't remember what that does. Oh, neat. Made things dark with the lights in the front. Doesn't really matter that much for what I'm doing. Braille mode. No idea. So if I turn the grid off or on, sometimes that might help us spot where things are at. And what's this arrows do? Oh, that just puts arrows on the ends of the axes of where they're showing. Not a big deal. All right, so I want to do something with zooming it in the X direction. I want to zoom out, and the Y direction zoom in a little bit. And I can see, just eyeballing it here, that it looks like the things that are important to me happen between -5 and 5. And I am not entirely sure why it did what it did. Okay, so my x-axis and my x-axis, -5 to 5. Okay. If you notice what it did there, it zoomed things in such a way that we could see the stuff, from x equals -5 to 5. Once you get in there a little bit, you can see a little better that maybe we could have gone down to -2 to 2, and that gets you a little bit more detail. Now I kind of want to be able to see those peaks, and it looks like the upper peak is around +20 and the lower peak is around -20. It looks like that upper peak's a little bit more than that. So I'm going to say -20 up to +25. And that should get me there. Okay. Now, if I want to see those intercepts, the 3 x-intercepts that I've got, -1.46, 0.05, and 1.448. The default on this tends to go 3 places past the decimal. So that suggests that the 1.46 and the 0.05 are something that rounds to the 2 places past. And I'll also put on a label there of the 0, 1. If you want to find a maximum or a minimum, hover near them, and Desmos will try to show those for you. Okay. Now, if you have some other point that you would like to illustrate for some reason, let's look over here, and maybe I want to use, let's see, it looks like -1, 20 is a point on the graph. And if you notice there, it'll let me label it. And I can label it to just say some point on the graph. Okay. And for that matter, and this I think is kind of neat, if you undo the point, it will just put a label there around -120. So if you want to label somewhere for some reason, then you can get a label there. And it can be a label for a point, or it can just be a label. Kind of neat. If you wanted to look at where this intersected something else, like maybe I wanted, x squared plus y squared equals 2. Okay. Now, as you can see, I don't have things that are very square there because my scale is different in the X and Y direction. It makes my circle look like an ellipse, but you know, the price you pay. And if I want to find the intersection, I can just hover close to where they intersect at and get intersection points. Not real rough to do. So if you want to do a horizontal or vertical line, you'll type y equals this, x equals that, and you can put lines in there wherever you want. Okay. One thing that's kind of nifty to do is if you like had an asymptote or something you wanted to deal with, maybe here I want to put in x equals 1 as an asymptote. Now that is fine to do, but the thing with it is that you might want it to be a different color. So you take and long click on it, and you can change it to be blue or red. I assume there's some custom colors you can get somehow as well. But for me, it's also handy to change it into a dashed line so that I can visually see that it's different from the other lines. Okay. And then if you wanted to, you could go ahead and say, oh, somewhere around 1,10, have the label on there that x equals 1 is your asymptote. And I'm going to have it like so. Okay. And if you look at that and say, oh no, I don't like that, I want to scoot it a little bit over to the side, you can experiment around with where exactly you want it to set at. So, yay! But you guys need to be, you folks need to be able to turn in an assignment. And that's a little trickier here. The thing that you'll want to do in order to do that is to take a picture of it. Now, first thing, don't get your phone out. That's not how you take screenshots. It's, yeah, drives me crazy when people do that. There's a couple of ways to do this. I'm on a Mac, and so I have a particular hotkey sequence to do. I want to take a picture that's not the whole screen. If I wanted to do the whole screen, I would hit Shift-Command-3 and would take a picture of the whole screen, and it would dump that onto my desktop. I want to take just a picture of a portion of it, so I'm going to say Shift-Command-4. Now, there's no special rhyme or reason for why it's Shift-Command-4. You just have to memorize that. Then go to the upper left-hand corner of the area you want to take a picture of and drag across to the lower right-hand corner of it and let go. I don't know whether y'all were able to hear that, but there was a sound that was like an old-fashioned camera taking a picture. And I have just opened another window, which I think y'all can see. It shows me a picture of what I just snapped. And I click on Done, and it has a file saved to my desktop, which is named screenshot something or another. You can open that with Preview, change the name, turn it into a different file format, whatever you need to do. But that's something that we can deal with a Jamboard here in a minute. Okay. All right. So that's kind of the basics there. And now I want to show you a couple of neat little tricks. One of the little tricks has to do with sliders. So I typed y equals a cosine x, and it automatically said, do you want to add a slider for a? I do. And then I'm going to go inside there and have a cosine of x and then plus b. Okay. And I'll tell it to do a slider for b as well. And my ranges are not very good for what I need here. So I'm going to say from negative 10 to 10. And then my y-axis, I'm going to say negative 5 to 5. Okay. And that should give me plenty there. Now, if you've taken trigonometry recently enough to remember such things, you know what the A and the B do. As I take the A and change it, it changes the amplitude. If A is negative, it flips things over. And so I can change my cosine or sine waves doing that. This B here is going to do phase shifts. So it moves things left and right. Now, I let it just choose the default here for what the A and B were going to be, but it might be the case that I had something that I was trying to do with this. I'm going to go down here and draw a second graph, and it's going to be y equals, let's say, 2 cosine x plus, now let's say minus sine x. Okay, so that thing that's in green, I'm going to take and make it into a dashed line, and I'm going to try to figure out values of A and B that make this this red graph match up with the green graph. So I'm going to start with the A. There's no real reason for that, but I know that I need that to be fairly large there. That's probably not quite it, but it's looking like A of 2.2. Now I'm going to take and click and change those A values and say, I want something between 1 and 3, and I want to step through in steps of 5 1,000ths. Okay. So the reason why I wanted to do that is that now I can step through and get very small detail. It looks like it doesn't want to let me use less detail than 1/100th. So, you know, what can you do? Then I'm going to try to use my B to get this to match up in phase. And it looks like it didn't quite match up there in the amplitude. So I'm going to try to pump it down a little bit there. And I'm going to zoom in order to see a little bit better there. Looks like that. And I can't manage to get it quite perfect. And that just has to do with the resolution that's allowed on it. But it looks like it's saying that this y equals 2 cosine x minus sine x should match up pretty well with, I'm gonna make this disappear here. I'm gonna try to tell it to draw y equals 2.23 cosine of x plus 0.5. So that's the thing that it was showing there as matching up pretty well. Okay. And you can get these things to match up, you know, as well as you have the patience to actually do after that. The sliders let you get things pretty good, and then you can mess around with numbers and get stuff even better. All right. And I'm going to try to do one more thing here where I click on the button that says share graph. And hopefully you see the window that popped up that says share graph. It says share this link. And you can print or export image or embed, or you can hit copy, and then you can send an email to somebody that has a link to your graph. So those are all things that might come up sometimes that you want to be able to do. Okay. All right. Now I want to try to show you Another thing in the same sort of direction, but with the Desmos app. I asked them to put the Desmos app onto the iPads, so I hope it's there. If it's not, let me know, and I will ask somebody if we can get that taken care of. So let me find my, well, I guess I should show you this on mine. So share screen, cross your fingers, because earlier today I could not get the iPad to find the Mac. So screen mirroring, it can see the Mac and it can also see my Roku streaming stick in the living room. And it says that it was unable to connect, but it didn't even try. Okay, stop share. All right, I'm gonna try one more time. And if this doesn't work, then I'm going to have to give this a miss. Could not connect. Okay. So, yeah, so I cannot connect with the laptop that I've got here. Okay. All right. Anyway, the reason that I was trying to show you this on the iPad is the app for Desmos is pretty much like the website, except there's one aspect of it that's better. When you want to zoom in and zoom out, if you grab on the axis that you want to expand or contract, it will do just that direction. If you do it diagonally, then it will do both the horizontal and vertical directions at the same time. But if you do just the x-axis or just the y-axis, it's pretty neat. Then if you've got a picture like about what you want, then you can take a screenshot with your Mac, or I'm sorry, with your iPad. And if I remember right, the way you do that is to take your power button and your volume up button and hit them at the same time, and it should snap a picture and put it onto your photo roll. Okay. So then with regard to stuff on your photo roll, when you're viewing it, you can hit the share button, the AirPlay button, and you can share stuff across onto another Mac device or other apps that are on the iPad. And so one thing that you want to figure out how to do is to take and put those pictures up into your drive, okay? The reason you want to figure out how to put them up in your drive is the thing I'm about to show you here, okay? So I have gone back to Desmos, and earlier I had that picture, and so I am going to go over here and hopefully be able to look at my drive. And once I get that, then on my drive, I'm going to go to my spring materials, 220 pages, and I don't have any pictures in here. So I'm going to take and hit new, file upload, and on my desktop, I have that screenshot, and I'm going to tell it to go ahead and upload that. It'll take a second, but it should upload it to this. I don't like having that super complicated name there, so I'm going to right click on it, rename it to be just screenshot.png. And I am going to go inside of, like, assignment 1 is a Jamboard. And on your Jamboards, there's a picture, there's an icon for add image. If you go ahead and click on it, it will allow you to browse on your computer and upload stuff, or it will allow you to look on your Google Drive. And so on my Google Drive, in the appropriate folder, I've got this screenshot, and boom, it drops a copy of that into my Jamboard. Several of y'all already have that figured out, so you know that's no sweat, right? But if you didn't have it figured out, now you've gotten just a little bit more idea about it. If you click the other options, it allows you to duplicate the picture or to delete the picture. If we had more than one thing there, you could have an order where, you know, one thing overlaps the other and stuff like that. Okay. So insofar as getting graphs, that's what you do if you want to do something with Desmos. In addition to Desmos, you might also do another thing here. I'm jumping back over to Drive. I'm telling it new, more, and I have something called Google Colab. If you have any interest in programming, you should go find out about Google Colab and just experiment with it a little bit, okay? If you are not interested in programming, go get interested in programming. Programming is going to be the new literacy. If you are involved in a STEM field, you should know how to do basic Python programming. Not complicated stuff, just basic Python programming. Okay, so I am going to show y'all how to do a graph in Colab, and then you can Google graphs in Colab and watch YouTube videos and learn all kinds of super cool things about it. Okay, but the simple end of things, you need to know about this sort of thing. I'm going to tell it code-wise to import Numpy as NP, okay? Numpy is a package that is full of all kinds of useful tools. My importing it says, let this program use the Numpy package. My referring to it as NP is just going to make sure that I can go back in and say np dot and get whatever tool that I need, okay? And then I'm going to say import matplotlib dot pyplot as plt. That should seem pretty arcane to you. Matplotlib is a package that does every graphing thing you have ever thought of and then some. And pyplot is a particular thing that's it's just a nice plotting sort of thing that has lots of the sub packages in it. Okay, we want to import it as PLT because we will frequently reference things and say things like plt.plot. Okay. All right, my next thing here is I'm going to get some X values, and I want to do a plot that's like a sine wave. Okay, so I'm going to get for my X values X equals np dot lin space parentheses, and let's go from 0 to 2 times pi, but pi is going to be inside of numpy, so we got to say np.pi, comma 100. So what that is going to do for you is to get your X values to go from 0 to 2 pi, and it's going to have 100 little divisions in there, okay? And then for my Y values, I think I said I wanted to do a sine wave. NP is the package that's got, Numpy's got the package that has sines in it and cosines. So I'll say sine of X, okay? So now we've gotten X values and we've gotten the Y values that correspond to the X. Once you have that, you can say plt.plot parentheses X comma Y. And I hit Command Enter to tell it to evaluate all this stuff. And I might have typos. If I had typos, it would give me some errors and I would just have to go figure out what they are and correct them. So you can see that we've got that sine wave there. I don't know about y'all, but I feel like it would be handy if I had for reference there a flat line. So I'm going to go back and say plt.plot x comma np.zeros underscore like x. Okay. What that does is take your x coordinates that we already had, and then it associates a 0 for each one of the x coordinates. The zeros like means to go back and look at x and see how far they should go and how many there should be. So when I plot again, it goes ahead and puts them on the same graph. And notice that it changed colors so you could see that, tell them apart a little bit easier. If you have a particular color that you want, you can say it here. I think you can type out the word color equals. If you want black, for some strange reason, it's K. So that made my plot into being black. And maybe that horizontal line there, I want that to be not black or blue. Let's say green is probably G. And I want it to be a dashed line. I think I can say G dash and it'll do it. I was wrong. So I'm going to put G dash dash. Aha, that turned it into a dash line. Okay. But I could also say dash dot, and then it'll just make a different pattern for it. And there's a lot of different options that you've got there. Okay. So, once you've got a plot like that, if you just go ahead and right click on it, you can copy it and paste it into something, or you can save it somewhere and things like that. So drawing graphs and stuff, it is relatively straightforward to do things with Desmos. If you want to be able to do some tricks, if you want to make your graphs, pardon the puppy metaphor, but if you want to train your graphs to sit up and beg for treats and stuff, go learn just a little bit of Python. And Colab is a free installation of Python that you have access to already through your Gmail. So go take a look at that and figure out what's going on with it. If what you're saying to yourself at this point is, I'm not required to do it, I'm not going to do it. Okay, up to you. But it's a good idea to go look at those sorts of things now instead of having to try to figure them all out at the end of the semester when technology presentation stuff comes up. So, all right, anyway, that should get you all going and, ask questions and stuff like that, but I'll see you in class. All right, take care.